Honors Chemistry. I am going to do 16A today, just giving you an overview because I have put up good videos, but still sometimes you just like to see me and hear me do it. And I miss you, I really do. Um, First of all, definitions of acids and bases. We're going to get into the nitty gritty of that in this chapter, but basically, everything around you is either acidic, basic, or neutral. Pure water should be neutral. But the minute you start dissolving things in it, then it changes it. It becomes either acidic or basic. Ammonia, bleach, anything used in your household is either acidic or basic. So acids have sour taste. So grapefruit juice, sour taste. Orange juice has acid in it, but it's also got a lot of natural sugars, so it kind of covers up the sour taste. So vinegar, sour, those are acids. Don't taste everything. It also turns litmus paper red, and a way you can remember that is acid ends in red and red. I say that every year. Acid ends in D and red ends in D. Bases are bitter, slippery. If you ever felt bleach, it feels slippery. If you ever felt, soap is a real good example of a base. So if you think bases, think soap. Your parents ever made you eat soap? Anyway, it's bitter, it's slippery, and it turns litmus paper blue. And you can remember that because base starts with B and blue starts with B. Turns litmus paper blue. So those are some basics of what acids do. They do a lot of other things. They react with bases to have a neutralization reaction, which is what I put up here. If you ever spill an acid, put baking powder on it because it reacts with carbonates as well. But you can also pour a base on it and make it neutralize, but that's not a good idea. Carbonate's a better one. But anyway, hydrochloric acid and sodium hydroxide are both, one's an acid and one's a base. If you mix an acid and a base together, they will do what's called a neutralization reaction. And if you mix them in equal amounts so that there's no leftover acids and bases, it'll form a salt and water. Now, a definition of a salt in chemistry is basically a positive ion and a negative ion put together. The positive ion can't be H plus and the negative ion can't be OH minus. But any two other positive and negative ions you put together will form what's called a salt. So when I say salt, I don't just mean table salt, but this does happen to make table salt. So a neutralization reaction, an acid and a base, these are very strong, very dangerous. Put them together in equal amounts and it makes harmless salt and water. So that's what's called a neutralization reaction. And you can write it for any acid or base, it's a double displacement reaction. If you remember, just swap your two positive ions. Now there are three theories about acids and bases, and I'm going to outline them quickly. Arrhenius said that an acid is something that gives off H plus ions in water. These have to be in water. It's in a solution, in an aqueous solution, okay? So acids give off H plus ions in water and bases give off OH ions in water. And that accounts for most of your acids and bases. But it didn't account for everything. For example, I mentioned ammonia was a base. So ammonia has no OH ion in it to give off. So that Arrhenius did not cover all the bases. But that's the Arrhenius theory. Bronsted-Lowry were a pair of Danish, I think they're Danish, scientists who came up with acids are proton donors. Now proton, you know what H plus is? Basically it's a proton. It doesn't have a neutron, so all it is a proton and electron. Once you get rid of the electron, all you've got is a lonely little proton. So really, H plus is a proton. So acids are proton donors, which means they give them away, and bases are proton acceptors, which means they take them. And they came up with something called an acid and a conjugate base, acid and a conjugate base, and a base and a conjugate acid, which means water acts as an acid if it gives away one of its H pluses. And when it gives away one of the H pluses, it's left with being an OH negative ion, which is definitely a base, because if it goes the other way, it will accept the H plus back and become water. So an acid, a Bronsted-Lowry acid, becomes a Bronsted-Lowry conjugate base. The base, in this case I put ammonia, it accepts that proton. See, on this side it only has 3, this side it has 4, so in other words, it accepted the one given away by this. So this base becomes the conjugate acid, which is the ammonium ion in this case. So you always have acid-base pairs in a Bronsted-Lowry equation. And so you notice, you didn't have to have H plus ions and OH ions floating around, even though this does create OH ions floating around, which is why this solution will be basic. Lastly, Lewis. The Lewis theory says acids can accept an electron pair and bases can donate an electron pair, and that's really all you need to know about these. It's a newer theory, and you can read what's in the book about it, but we don't really do a lot with Lewis acid-base pairs, but they can. Acids accept electron pairs and bases can donate electron pairs. So that is 16A in a nutshell. Go ahead and watch the videos, and I'll be back with more.